Proving conjectures. Deductive reasoning. Alright, so section 1.4 is titled Proving Conjectures, Deductive Reasoning. There are several definitions that you should either write down or memorize or something. So a proof is a mathematical argument that shows a statement is true in all cases. No counterexample exists. A generalization is a statement or idea that has a general application. A premise is a statement that is assumed to be true. The transitive property, that if A equals B and B equals C, then A equals C. So how can we represent numbers in a general sense? We assign them letters, yay! Example, let x be a number. Or if we want to, we can make it more specific. So we can say let x be an integer. Some generalizations for proofs. You have a sheet online that you can download that has all of these on it. So n would represent a number. N and n plus 1 would be two consecutive numbers. 2n is an even number. 2n plus 1 is an odd number. AB is a two-digit number, and ABC is a three-digit number. Example 1. Try to prove the following. Whenever you add 5 consecutive integers, the sum is always 5 times the median. So, to prove something, we're going to use things called two-column proofs. You have a statement, and then you have to explain or justify your statement that you make. So, I said, let n represent any integer, because I'm dealing with integers. So let n represent any integer. Let s represent the sum of 5 consecutive integers. So here's my sum. S equals n minus 2 plus n minus 1 plus n plus n plus 1 plus n plus 2. So I chose n to be the median and wrote a generalization for the sum. Then I simplified the sum by combining like terms to end up with s equals 5n plus 0. Well, since 0 is 0, I can just say that s equals 5n. So since n was the median of 5 consecutive integers, 5n will always represent the sum. So I've just proven that the sum is always 5 times the median in a set of 5 consecutive integers when you add them all together. Example 2. Prove that the difference of consecutive perfect squares is always an odd number. So again, I'm doing a two-column proof, having a statement and justifying my statement, or explaining it. So my statement is, let x be any natural number. Natural numbers are the numbers 1 to infinity. So we deal with the integers greater than 1 when we're dealing with perfect squares. This is known as the set of natural numbers. My next statement is let d be the difference between consecutive perfect squares. Alright, so d equals x plus 1 squared minus x squared. D is the general statement. The smaller square will be x squared, and the larger will be x plus 1 squared. And then I expand and simplify to get d equals 2x plus 1. So expanded and simplified, since x is any natural number, 2x plus 1 represents an odd natural number. So I have just proven that the difference between consecutive perfect squares is always an odd number. Example 3. All dogs are mammals. All mammals are vertebrates. Sheba is a dog. What can be said about Sheba? For this one, I'm going to use a diagram. So, all dogs are mammals. So I have dogs. All dogs are mammals. All dogs are mammals. So dogs are within mammals. But all mammals are vertebrates. So all mammals are vertebrates. Sheba is a dog. So here's Sheba. Sheba is within dogs. Shiba is a dog. What can be said about Shiba? Well, by looking at my diagram, I can see that Shiba is a dog, a mammal, and a vertebrate. So I can say Shiba is a mammal and a vertebrate. Done. That's what can be said about Shiba. Example 4. Prove that a two-digit number is divisible by 3 if the sum of the digits is divisible by 3. So I have a statement and justification. This is called a two-column proof. So my first statement, let AB be a two-digit number. So with any two-digit number, you can write it as an expanded number, like 21 equals 2 times 10 plus 1. So that's what I did. AB equals 10 times A plus B. Then I wrote an equivalent sum. AB equals 9A plus A, which if you add these together, you get 10A, plus B. So this is an equivalent sum. Since 9A is divisible by 3 because 9 is divisible by 3, we know now that AB is divisible by 3 only if A plus B is divisible by 3. Ta-da! That one's done. We've just proven that a two-digit number is divisible by 3 if the sum of the digits is divisible by 3. In this case, our digits were A and B. The sum of the digits are A plus B. Done. Prove that when two straight lines intersect, the vertically opposite angles are equal. Start with angles AEC and BED. So I have a diagram. Here's my diagram on the right side of the page. This is the diagram that I'm going to be referring to. So angle AEC plus angle AED, angle AEC plus angle AED equals 180 degrees. Because they're supplementary, they form this line. All right? And then, by the subtraction property, I can say that AEC equals 180 minus AED. Then I take a look at angle BED. So angle BED plus angle AED is equal to 180 degrees because they form a line. This is the supplementary angle property. And then by the subtraction property, I can say that BED equals 180 degrees minus angle AED. By the transitive property, remember, the transitive property is when A equals B and B equals C, then A is equal to C. I can say that that angle AEC is equal to angle BED. Why? Because AEC is equal to 180 degrees minus angle AED. But so is BED. BED is equal to 180 degrees minus angle AED. So because these are equal, A is equal to B, B is equal to C, then I can say that A is equal to C. This is the transitive property. So your assignment is on pages 31 and 32 of your textbook, numbers 1, 2, 4, 5, 6, 7, 8, and 17.